Getting through notes pretty quick today. So I'm with this second function. I didn't get to write average rate of change and ratio of y values because I'm a loser, but let's just pretend those are there. Okay, here's the average rate of change. I'm going to go 32 minus 16. 32 minus 16 over negative 1 minus 0. Let's see, that's going to be 16 over negative 1. That's negative 16. Then for the next one, I'm going to go 8 minus 16 over 1 minus 0. That's negative 8 over 1. That's negative 8. I can tell this isn't going to work. I'll do one more just for funsies. 8 and 16, so I'm going to go 4 minus 8 over 2 minus 1. That's negative 4 over 1. That's negative 4. This is not constant, so it's not linear. So I could write the word linear down here, but I got to cross it off. So then I'm going to go with the ratio of the y values, and let's see what happens. We go 2 divided by 4. That's equal to 1/2. Okay, 4 divided by the previous y value, 8, that's 1/2. 8 divided by 16, that's 1/2. 16 divided by 32, that's 1/2. These are all the same, so this graph is exponential. And I ran out of room, so I'm going to pretend I meant to abbreviate that on purpose. Okay, we'll go to the third one. Average rate of change. Okay, here we go. I'm going to go 2 minus 4 over negative 1 minus 0, and I get negative 2 over negative 1. I get a slope of 2 in between those 2 points. That was these 2 points right here. So now I'm going to go 4 and 7. I'll go 4 minus 7 over 0 minus 1, and I get negative 3 over negative 1. That's equal to 3. I'm going to stop right there because it's clearly not the case that the average rate of change is constant. So I go to ratio of y values. Okay, 16 over 11. I don't know what that is as a decimal. I'm just going to move on. 11 divided by 7. Well, see, now I should know what those are as decimals. Let me go. This is 1 and 5/11. This is 1 and 4/7. Those aren't the same. Let me keep going. 7 divided by 4. That's 1 and 3/4. That's definitely not the same. And if I go with 4 divided by 2, that's the nail in the coffin right there. Those are definitely not equal to 2. So this one is neither. It's not linear, it's not exponential. Okay, last thing for us today. Quick on the notes today, not much on the homework today. We're going to do that today, and we're going to do it on Wednesday. And I'm going to finish. I'm actually going to have a day 3 for this so we can talk about all of it when we get back and kind of bring it all together. If I'm going to graph the exponential function f of x equals a to the x, for a is greater than 1. We'll talk about a different a on Wednesday. The domain is negative infinity to positive infinity. That's the domain. The range is 0 to positive infinity. You can see from our graph here, this is from our dots we put on the page, this is never going to be negative. If I put in negative numbers, I just put something bigger in the denominator, and it's just going to get closer to the x-axis, but it's never going to be negative, and this is going to take off. So the range is everything above the x-axis. The domain is all real numbers. Okay, there are no x-intercepts because we never hit the x-axis, and the y-intercept will always be 1 because if I put a 0 in for that x, anything to the 0 is 1. The end behavior will go like this. As x approaches negative infinity, y approaches 0. But as x approaches positive infinity, y approaches positive infinity. Approaches 0 over here, positive infinity over there. It's going to look like this every time. The graph is increasing. Oops, I wrote that way too big. On the interval negative infinity to positive infinity. And y equals a to the x, this will be important to us next week, is a 1-to-1 function. So I'm going to sketch the graph of 2 to the x and 4 to the x, and we're done today. I'm going to have the point 0, 1 in there. I'm going to have a horizontal asymptote at y equals x. I'm going to put 1 in, and when I put a 1 in, 2 to the 1 is 2. When I put a 2 in, 2 to the 2 is 4. 1, 2, 3, 4. When I put a 3 in, 2 to the 3 is 8, so that's up here. When I put in a negative 1, I get 1/2, I get 1/4, I get 1/8, I get 1/16, 1/32, 1/64. It just keeps getting smaller and smaller. So I just kind of draw it just above the x-axis. Make sure you go through the point 0, 1, and that takes off. That's the point 0, 1. That's the y-intercept. Okay, and then I want you to see the difference between 2 to the x and 4 to the x. So it's going to go through the point 0, 1. It's going to have y equals x as a horizontal asymptote. It's going to just stay just above this line and hit here. Now, when I put in a 1, 4 to the 1 is 4. 1, 2, 3, 4. 4 to the 2, when I put a 2 in, it's 4 to the 2. That's 16. That's way up here. So what happens is this one takes off a lot quicker. So it's a little more steep right here. Okay? There's your notes for the first day of section 5.3, and there's a little, won't take you very long assignment on section 5.3 on my math lab. Have a good Monday, everybody.